Our next keynote address is by Gendron Venugopal, Senior Vice President and CTO Myntra. Jay is leading the technology function at Myntra, which is the undisputed leader in India in fashion e-commerce. He leads the storefront software across all the mobile and web platforms, supply chain systems, data platforms, analytics, insights, data sciences organization, innovation labs, as well as the corporate IT function and DevOps. So now I'd like to invite Jay on the stage. Thank you.
Good morning, everyone, and thanks, Devika, for that introduction. It was really inspiring to hear the journey of Nephroplus, and also Bharat had set context about how basically software as a field is actually changing the world. In fact, the things he talked about, right? Like if you look at the GEs of the world, which own interests as diverse from consumer durables to, let's say, energy and power to aircraft engines and have hundreds of billions of dollars. The market cap for that is actually less than many of the 10-year or less older companies that have just recently come on the horizon, right? And Mark Andreessen actually very famously summed it up when he said in 2011 that software is eating the world. Right, and today we have gone on to the next paradigm of that, right, which is that software was being written by humans for the most part, right, like meaning that the algorithms were hand created by humans. Now algorithms are being generated out of statistical inferencing and machine learning, right, so basically data is generating the algorithm in essence by itself through the machine learning techniques, right. So a lot of the deep tech stuff that we are going to talk about now is, in fact, I would say is like software is eating the world and machine learning is now eating software, right? So that is the paradigm we are now going to. So I'm going to focus basically on three areas of deep tech. So three areas of deep tech, which I believe are transformative technologies that are going to not only just create the next biggest opportunities for entrepreneurs in the IT-enabled services sector, but also are going to really change even the social fabric, and why I believe that is going to be the case. So I'll talk about that. So again, in terms of context, why are we talking about it in this forum, right? So I would say there are probably entrepreneurs who are starting new ventures, trying to figure out how to disrupt old world economies. What should they be looking at as the lever for them to bring a new element to their business models, etc. Right? So if that doesn't happen through some of the technology that is coming along, that is going to anyway come and disrupt this ecosystem, then the entrepreneurs may be missing out on that changing trends. Right? So that is one big reason why we are talking about that. The other thing is also, I'm sure there are people in the industry that are sitting here as well. I'm sure you're thinking about what should I be doing within the context of my enterprise, for example, that I should be doing differently to reinvent how we are thinking about our business model and so on, right? So hopefully some of the things I'll talk about are going to be good pointers to both these segments, startups looking for new ways of driving innovation as well as corporates. So the three big areas that I'm going to focus on are basically machine learning, artificial intelligence, deep learning, reinforcement learning, etc. The second big area is basically around augmented reality, virtual reality, mixed reality, and what are the industries that it's already making a huge impact on, and what are the kind of applications we could see for those. And of course, the third one is blockchain, right? And how blockchain is actually going to be very, very disruptive to a lot of traditional industries. So those are the three areas that I'm going to focus on. Basically, just to, while it looks like there is always some presentation issues that happen, right? So while they're sorting it out, let me just start talking about machine learning and where we are in that journey and landscape, right? So machine learning is not really a new thing, right? So the term artificial intelligence was in fact coined as far back as 1965, right? And nobody really heard much about it for very long, for very many years. And like earlier when you talked about artificial intelligence, people talked about expert systems and very heuristics, rule-based systems, etc., right? And then suddenly like 20 years back, we saw that everybody woke up when suddenly they heard that artificial intelligence system actually beat the grandmaster in chess at that time, who was Garry Kasparov, right? So Deep Blue actually did that, and then suddenly there was a surge of interest. And then if you look at the sequence of things that have happened after that, right? So basically a lot of accelerating innovations have come over the last 10 years, 20 years, right? So it took 40 years from the concept being coined to basically a chess grandmaster being defeated by a what we call as artificial narrow intelligence system, right? It's not really a broad system that could be applicable beyond that one particular use case, right? So, and then that took 40 years. And then somehow in the last 10 years, it seems like you're seeing a flurry of new things happening, from machines now being able to do computer vision much better, speech recognition way better than what they would ever they were ever doing, natural language processing. So every field that you hear about is now being transformed by machine learning and its variants, right? So why is this happening? What has actually changed in the last 10 years that is making this big transformation happen, right? So basically, if you look at it, there are three big things, the three big trends that is actually powering this big shift in the landscape of why AI/ML is now emerging as having a lot more real world applications, right? So one of the things is basically around just the availability of raw compute. I think Murphy's law actually, Moore's law actually played out, and we had doubling of computing power almost every 15 to 18 months on average. That kept happening over a long number of years. Then of course saturation started happening on Moore's law, and system has been figured out. So we'll continue. So sorry about the kind of the disruption that happened in the presentation itself. So anyway, let's talk about what I mean by disruption and reinvention through these new technologies that are emerging. So, so this I talked about already, right? So I'll skip through quickly on that. So if you look at the pace at which innovation is happening, powered by machine learning, you can see that there was like a long number of years before a particular milestone came along. People woke up and said, yeah, it's great, right? Something new is happening here. And now it's coming at such a thick and fast pace. The kind of breakthrough innovations, machines being able to actually recognize objects and images, which was always thought to be a very, very hard problem, right? It's happening already, right? Google's DeepMind, for example, is beating the world grandmaster in Go, for example, or self-driving cars and so on and so forth, right? You would have never thought that some of these are actually possible even 10 years before, right? So, and that's now a reality, right? So why now? Why is this the right time for the emergence of basically machine learning, and what has actually changed this time around, right? Because it has had a couple of false starts already. Is this going to be yet another false start? I firmly believe it is not the case. This time it is actually qualitatively very different, right? And why is that, right? Is if you look at the emergence of computing power and where we are today. So like a Cray supercomputer, which was the fastest in the world, not too far back, right? This was basically in the early 2000s, and you compare it to just phone that you can buy for a few tens of thousands of rupees today, right? So basically that phone is 10 times more powerful than the fastest supercomputer that existed in the world not too long ago, right? It's just about 15, 18 years back. And the entire space program for Apollo was actually powered by a system that is 400 times less powerful than what you get in a consumer grade, relatively cheap hardware device like a PlayStation 4 today, right? So compute power and how Moore's law played out has played a big role. And this is just so in the bottom you see the projected number of computations per second that happen in the brain of, let's say, ant to a wasp to a human brain, and a collection of everybody in humanity, 10 power 26, right? 10 power 16 is what neuroscientists estimate is the number of computations per second that happen. So if you look at how much of compute power you can get for $1,000 price and how that has changed over the years, and how it is projected to change, you can very well see. So today, for example, there are supercomputers that are available that actually have already surpassed in terms of the petaflops of computing that they do compared to how many computations happen in the human brain today. Right, so that is one big factor in why qualitatively now machine learning is different. And so this is, and the second big part is machine learning is, the fuel for machine learning is actually the infrastructure, if you may call it that, the engine is the compute, and the fuel actually that goes into that car is actually the data, right? And the explosion of data has been another big factor. So since I started talking from this slide, you can see the counter ticking down, right? So basically, before it reaches 0, basically in 60 seconds, the world would have done 4.1 million Google searches, would have streamed about 4.5 million minutes of YouTube videos, and so many tens of millions of emails being sent, right? So there is a huge explosion of data. Every device that you're carrying with you, your phone, is always generating data and pushing it to some cloud, right? Your carrier's cloud, the applications that you're using are getting that data onto their cloud. So this whole huge explosion of data is actually, again, fueling a lot of the growth of machine learning. And of course, the big data platform and tools, engineers have also contributed in their own way. It is not just the data scientists and the computer architecture folks that have powered this. Engineers obviously have invented completely new paradigms for doing data processing at scale. MapReduce obviously kickstarted some of it. Now we have moved on far beyond that as well in terms of stream processing, etc., for analytics and a lot of different use cases, right? So basically a combination of all of these are actually what are powering the next wave of innovation in machine learning, AI, deep learning, and other things like reinforcement learning. So let's look at something, right? So if you look at what happens, so what is deep learning today? That is the next big cutting edge thing that is powering a lot of the big breakthroughs in machine learning, right? So machine learning used to be only about statistical inferencing, essentially. If you break it down to the bare bones, it is about statistical inferencing and then having algorithms that do it very well by crunching a huge amount of data, right? So now we are moving beyond that, and then we are looking at what is being called as neuromorphic computing, right? So how do you actually draw inspiration from the human brain itself? Because after all, for a 2-year-old, for example, right, we are not teaching probabilistic inferencing to a 2-year-old, and then the 2-year-old is not using that to recognize that once his or her mother or father have taught that child that, hey, this is what you call a cat. The child is now able to recognize that cat in various different colors, various different poses, in various different mediums, right? Clearly, the child has not been taught any probability and statistical theory or Markov chain processes or any of that, right? How is that happening, right? So that is what now computer scientists are now starting to look at and starting to work closely to try to replicate using neuromorphic computing, right? So if you look at so for a minute, if you step back and think about how the human brain does its job, it is just like mind-blowing, right? It's amazing. I mean, with all the advances we are going to talk about, we still haven't really reached the level of sophistication and capabilities of what a human brain could do, but we are fast getting there. So just think about it for a second, right? Anybody now seeing a cat, for example, what happens behind that, right? So there is light bouncing off the cat that is reaching your eyes, and then that is actually triggering some electrical impulses going through the neural interfaces, and there is something called activation potential that actually triggers in the synapses based on the synapse actually learning through repeated exposure to stimuli, right? And then that is what is eventually reaching the brain. So from something like that, how do you get so basically that is triggering a certain level of like if you look at a fMRI image today, you will see that when certain objects, the subjects are thinking about certain objects, real world objects are being exposed to stimuli that reminds them of an object, let's say on a screen, right? So there are certain areas of the brain that light up. How do you go from that to a subjective qualitative inference out of that, oh, this is a cute cat is what I'm seeing, right? Like how does that actually work, right? So that is what deep learning is trying to now replicate by means of the infrastructure, right? So why is it called deep learning? Because there are lots of different layers, and the raw stimuli that is coming in is going through lots of, so each of these layers that are getting trained through repeated exposures to the stimuli, and each layer actually is trying to hierarchically infer more and more intelligence about the stimuli, right? So deep reinforcement learning is basically a variant of deep learning. Reinforcement learning so there are algorithms like Q-learning, for example, that do this. So here what you do is you are actually, the reinforcement learning mechanism is trying to operate in the real world with what is called as an objective function. So it's trying to continuously optimize the objective function. So that is what its goal is, right? And AlphaGo, for example, defeated Lee Sedol, who's a Dan 9 player, one of the very few, if not the only one in the world today, a grandmaster in Go. And Go, for example, we probably don't know too much about Go. It's a much more Far Eastern game. I'm sure most of you know about chess though, right? So chess is considered a fairly complex game, right? So if you look at chess, the possible universe of board configurations that exist is about 10 power 120, right? And the possible configurations of the Go board are basically several trillions to trillions of magnitude more in terms of like 10 power 176 configurations are possible, right? It's a very, very complex game, right? The rules are very simple, but the possible configurations and the strategy elements in the game are extremely complex, right? So even when Garry Kasparov was defeated by IBM's Deep Blue, I don't think at that time anybody, if you ask even the computer scientists, they would have said that this feat would have been possible to replicate in Go, right? And that just happened, right? So Lee Sedol, you can see him intensely concentrating on the board, right? And since then, again, within a few months, actually, even AlphaGo has been surpassed by the next generation of the algorithm, which was actually called AlphaZero, right? AlphaGo at least needed a lot of corpus of human games that needed to train on. AlphaZero did not even need that. It just needed the basic rules of the game input into it, and then it started playing against itself, and it trained itself. And within about 3-4 days of that continuous training, it ended up beating AlphaGo, right? And it is, so now this is actually an application of reinforcement learning. People are doing this to basically teach how robots have to walk, for example. How many of you, I don't know if you have seen Boston Dynamics and some of its robots trying to navigate real world terrains which have a lot of slopes, barriers and other things, right? So this whole thing is powered by reinforcement learning. So I'll just play this video. It'll look very goofy, but you'll see some very interesting things here when this happens, right? So this robot has been actually trained by means of purely an objective function that is trying to optimize. So no rules have been input into the system, no physics has been taught to it, etc. Right? Sensor inputs are being programmed, and you can see barriers are being put in the landscape it is trying to navigate, and it's doing very interesting things, right? So the virtual sensors are giving it inputs about the simulated real world, and this robot is trying to navigate that space, right? So imagine trying to program this using rules like subjective rules or heuristics that you program into the process, right? It's just not going to work, right? So but if you look at this here, so the robot, through repeated attempts, repeated failures, and then continuously trying to tweak its own internal mental model, it's actually learned this by itself, right? It's just like, if you just stop to think about it, it's just amazing, right? It has learned that it has to actually time its jump at a certain distance before the edge of the plank, etc., to be able to reach the optimal point on the next place, right? And of course it doesn't always work out, right? It falls, and that is exactly how it learns, right? It knows that its objective function has now been dented by the move it tried, so next time around it will actually try something slightly different, right? And if you look at it, so it will come further down in the video, it will do some very interesting maneuvers, right? So you will think that out of the box thinking is basically only for humans, for example. So this is what it does, right? So you would think that a robot that has been trained using barriers will always try to jump over barriers, but you can see that it's actually navigating around the barriers when it has space, right? And all of this is actually being done only through reinforcement learning, right? So it's just totally amazing to think about it. This is of course a Waymo car. It is actually currently in beta. The public is actually taking rides on Waymo cars right now. So one interesting thing for me to observe is looking at the passengers that are taking these beta rides, right? If a human were driving it, I'm sure all of us can bet what these two would be doing now, right? They are not going to be looking out the window. They'll be intently focusing on their mobile, right? So you can see here what is happening. And some of the times the expressions on their faces are like really precious to see, right? when they're sitting in a self-driving car. But just like, I mean, 10 years before, if anybody had stood on a stage and made a public prediction that there would be self-driving cars driving in real-world environments, they would have been laughed out of the stage, right? And this is today a reality. And let's look at some of this stuff, right? So this is actually a poem, right? So so let's just absorb the poem. It's fine. It's I would say trying to convey some emotion about what it feels like, or how a separation of friends or whatever, right, is looking like. So these are a couple of pictures. I just want you to absorb these things, right? Like I'll tell you what this is about, but let's just look at it. So there is some impressionist kind of art. There is some kind of a landscape kind of painting here, for example, etc., right? And I'll just let this play for a moment.
I wish I could see beyond what I can see.
So just pay attention to the particular music score that is going on in the background, and see if you can spot anything about the music score, right, from what you see here.
What isn't real? I wish I could imagine, yeah. There's more to who we are. There's more to what we could be. As I feel the weight of being, I'm learning how to break free.
So I'll stop there. So basically, what is common between these things, right? So you saw a poem initially, then you saw like some paintings of different kind of genres of paintings, and then you saw basically a album, a music score, and so on and so forth, right? So the common thing between all of these things is that all of these were actually generated by an AI system. There was no human involved in creating any of these pieces, right? So, I mean, people think that while AI, machine learning can do things which sort of look like what machines normally do, but they can't breach where a human actually can apply their creativity, etc., into the process. That is no longer actually true as well, right? Clearly, I mean, this particular last album, for example, it is titled I Am AI, and this was the lead song in the album. It's actually a single hit, actually. It's one of the most listened to songs last year, right? And it's a very, very good song. I would definitely urge all of you to listen to that song. Right, so that so this is being all of this new generative stuff, right? How do you actually replicate creativity in the process? Is being done through something called generative adversarial network. It's again a different application of deep learning. So this is based on something called a celeb A data set, which is like a public repository of celebrity faces, right? So here, what the AI system is doing is actually trying to generate new faces. So some of the faces you are seeing here have never existed in the real world. But if you look at them, you won't be able to say that these are artificially generated faces, right? So it is just like, I mean, just think about that for a second, right? Like how, I mean, how cool that is, right? And of course, I mean, some of this stuff requires some enormous amount of compute power, right? So people, of course, use GPUs, and now we have moved on even beyond GPUs. And now there are application-specific integrated circuits, tensor processing units that Google came out with, etc., that are actually now starting to help with some of these very compute-intensive tasks. But even the fact that some of this is possible is just amazing, right? And now switching gears a little bit, right? All of this may appear like somewhat, okay, research-oriented. How is it actually impacting real businesses, etc.? So I'll talk about something, what we have done using this last thing that I showed, which is the generative adversarial networks, right? So the fact that it can generate new paintings, poems, inspired us to think that it should be able to generate new fashion design as well, right? And that's what we did. So, so in terms of the motivation for the problem, I'll talk about how fashion generally works. Is basically, it takes a long time, almost 14 months for fashion design to go from a conception stage to products on the shelves, right? So that is how traditional fashion works. A lot of the time actually gets spent in the initial design iterations, right? And a lot of the initial design, the design concepts also come from the gut feel of the designers, right? So they're not actually doing any quantitative methods of understanding through social media or any other mechanisms in a scalable way what is emerging, what is trending, what could be trending, etc., right? So what we did was basically a new take on what we are calling as the next iteration of fast fashion, rapid. So this is, I mean, I work for Myntra and Jabong, so this is part of Myntra and Jabong's suite of AI tools that is powering a couple of our private fashion labels today, which are being completely designed through AI systems. So you wouldn't even know it, right? So we don't show it anywhere that it's designed by AI, and you wouldn't know it, right, by just looking at it. So the way it works is the AI system actually gets sales data input, and it does computer vision, attribute extraction, as well as uses any catalog inputs that it has. So computer vision comes in handy when it tries to scrape social media imagery, street fashion, what we call as street fashion, images of people wearing everyday clothes on the street, plus red carpet fashion, etc. And from there, we actually figure out what is it that we should be actually producing in terms of the next design drops that we need to do for the next season launch, etc., right? And so basically, if you look at, so let me just go fast a little bit. So the AI system also scores which of the designs that it produces are likely to be top sellers, bottom sellers. It manages the assortment entirely, how many of certain types of dresses I have to produce of different sleeve lengths, different collar types, different types of color patterns, graphic t-shirts versus solids versus something else, etc. Right? So all of this is being today driven in our systems through our AI platform called Rapid. Again, it's powered through deep learning and GANs. So you can see, for example, the deep learning layers, when it sees an image like this, through this hierarchical layers of processing, you can visualize that some of this actually corresponds to sleeve, some of this corresponds to like whether it's a varsity t-shirt or something else, etc., right? So it tries to extract the attributes just by looking at the image and then generating all the attributes out of it. And then it does the design iterations, right? As you can see, as you go more and more into the iterations, the design starts looking more and more like real design. Of course, you could see that it's generating designs where the sleeve length is different and so on and so forth, right? So it needs lots and lots of iterations before the design actually converges. And then finally, this is actually one of our machine-generated designs, right? So by looking at it, you wouldn't know that this was actually generated by a machine, right? It does a lot of very interesting creative things like fading patterns on the design and all of that stuff also, right? So, and in terms of results, you would think, okay, there's some experimental thing we are doing. No, not really. This is actually completely powering a label called Moda Rapido on our platform. And interestingly, that Moda Rapido line actually does 3 times the sell-through rate of any of our other normal human-generated design lines at 2x the margins, right? So the business results are already here. This is not anymore in the lab. It is out there in the real world, causing real-world impact. So I'll skip this because, just for lack of time. So that is all on the topic of AI, ML, deep learning, etc. Right? So how it is disrupting a lot of different industries, business models, including infusing creativity elements into the business models and so on. Right? So the next one I'm going to switch gears and talk about is actually about VR, AR, and MR. This is again, I believe, going to be one of the key things that is going to reshape how we consume entertainment, how we interact with even real-world objects and so on. And this is a little bit earlier in the curve, I would say, compared to, let's say, AI/ML. AI/ML has emerged a little bit more. This is slightly behind on the curve. But that is going to change very fast, right? So, of course, Google came out with this cardboard, then now Oculus Rift was there. Again, it was tethered model, very clunky to use, and it was very expensive. Now, Oculus Go has brought down the price point, increased the resolution. The same thing that we saw in computers, right, for example, is playing out here as well. It is going to get cheaper, it is going to get faster, resolutions are going to get better, and it is going to get mainstream very, very soon, right? It's just like it is only a question of time. 1 year, 2 years, it will happen, right? And what does it enable, right? It looks like, okay, it is something very weird, sci-fi looking, Maybe it will be used for very niche use cases and so on, but that is really not the case. So the application span a spectrum of industries that is pretty much like every possible industry you could think of could and will be disrupted by AR, VR, MR, right? So entertainment is a very obvious one. So you essentially, because it is so close to your face, right, you essentially get the experience of sitting in your own drawing room, your car, backseat, wherever it is. You are actually getting the experience of sitting in a fully immersive 3D IMAX theater, right? Like who would not want that when it becomes mainstream, right? Real estate, for example, you don't have to visit a place to actually experience it in the resolution which is very close to real world resolution. In a few years that will happen, right? So you can virtually visit and tour places, for example. And now it's not just visual input. Now haptic sensors are coming where you can actually wear haptic sensors and then not only see things but also experience the touch and feel of the something, right? Like it'll give you vibration feedback, touch feedback and all of that as well, right? You can only imagine in a few years that haptic sensors are now going to be like a full body suite, right? Then you're fully immersed in the environment that you're in, getting every possible stimuli that you can, right? Including possibly in the future even a smell stimuli could be there, right? So so then a lot of these industries will look very, very different, right? And in just a few years, training education, other big thing. So on the field, for example, when you're trying to actually repair things, one of the things that happens with AR is that it'll actually project, okay, unscrew this cap, do this particular tightening, etc., to field personnel that are actually just getting trained or that need help trying to repair complex parts, right? So those are real use cases that are already out there in the field, right? Social shopping, for example, wherever you are, you may be in different countries, you could be shopping together in a virtual reality world where both of you are seeing each other and then shopping together in a virtual e-commerce world, right? So these are some of the applications. These are some actual examples of innovations that have been done. Pokemon Go, I'm sure most of you know about. It's a game that took the world by storm when it came on. This is about projecting a dial face onto your hand to see, for example, when you see in a catalog, let's say in a Myntra catalog, different watches, right? It will give you specifications like, oh, the dial is actually this many inches in diameter, etc. But you really don't know, or how can you visualize how it will actually look on you, right? You don't know how big that whatever 2 inches is or whatever is compared to your wrist size, right? So now you can use like both Google, Apple have come out with AR Kit, AR Core, etc. that brings the power of AR to just your regular smartphone, right? And you can use the smartphone camera to project digital objects onto the real world. And these are a couple of examples that I'll quickly cover, right? So if you, shoe size finder is one thing that we have already implemented. One of the big reasons why we get returns, especially on footwear products, is people don't know what their size is, right? So there is a US size, UK size, and so on and so forth, right? There is a UU size, like nobody knows when you're trying to pick from that, and the size charts are also slightly different between brands and all of that stuff, right? So people don't know, and like they're not going to take a tape and sit and measure and put the right inputs. So we get a lot of returns. So we thought about how we could use AR to actually try and help the customers to get the right shoe size for them, right? So here you see that this actual application that's already deployed. It's part of our Myntra app. So you can actually see your shoe size by projecting a scale onto the real world image of your shoe and then measure it, and then immediately it'll tell you what shoe size you should buy. And this is another application that you would have seen the video of, where in beauty and personal care, when you walk into a physical store, you have the ability to like apply it on your skin, for example, or do some sample applications and see how a particular shade looks on you, etc., right? But that is not possible in the virtual world, right, in e-commerce. So we thought of how we can change it, and this is our take on it, right? So live makeup. Apply live makeup on yourself by just virtually clicking that, and it recognizes where your face is in real time. You can move around in the camera. It will not smudge it all over your face and everything, right? And it will actually show how it look on you, right? Including foundations you can apply, liners, you can apply lip color, whatnot, right? So that's a real world application that we are seeing a lot of engagement from customers on, right? So these are real uses of AR, VR. So again, I think whatever industry you are in, I would love for you to take back something that like these are some technologies that you can go back and think about how is it this could actually enable or transform your own industry. I am really, really sure that there is and there would be a way that this would be possible in any industry you are in, right? So on the last one that I'll quickly cover, because we lost a lot of time initially due to AR issues, AV issues, I'll quickly try and cover this, which again, this is again further behind in terms of, in my opinion, on the overall cycle. But again, this is going to be equally, if not more transformative to the industry, right? I'm sure there are more discussions scheduled on blockchain now. So people generally think of blockchain and equate it only with cryptocurrency because that is the only application in which this initially surfaced, but that they're not the same, right? Cryptocurrency may or may not really take off. For all you know, it could also be a very powerful driver of how international commerce actually happens, money exchange happens and so on. But even apart from that, blockchain is going to be by itself, in and of itself, outside of cryptocurrency, be an extremely disruptive force in the world. So at a very high level, blockchain is a completely decentralized paradigm where you don't need to rely on a central authority anymore. It's a distributed ledger, public ledger, and it's going to really create new efficiencies by eliminating middlemen. So just these are some of the examples. Imagine a stock exchange that is happening completely on a peer-to-peer basis, right? So when you do today a stock exchange transaction, you are ending up with basically a T+3 day settlement because there is an auditor in between, there is a clearinghouse in between, all of that stuff, right? None of that, right? No fees, no commissions, direct settlement and instant settlements, for example, right? Open Bazaar is actually, you can think of it as a blockchain distributed ledger equivalent of eBay. It's open sourced and it's starting to gain adoption. Transparency, governance, etc. Right? Middlemen, for example, so one of the big reasons why middlemen are there in the value chain is because they are a trusted party in between the different transacting parties, right? So they essentially act as escrow agents in the transaction, right? And that actually causes a lot of value sink in the entire value chain to go into it. I'm not saying that the middlemen don't add value. Clearly they add value, like some of them transport goods, for example, etc. Right? So that is definitely going to continue, but any value being ascribed only because of being a trusted intermediary or a trusted repository in between and doing escrow business is going to change. Right? So I will not go into too much detail. So again, I urge people to look at it. So this is the closing slide. So these are the two things I'll leave you with, right? So in terms of so I'll just let you absorb this, right? The first one, clearly these are three ideas that that are now really already starting to transform the world as you know it. And the last one is actually is a really nice quote that says, if you've always done it some way, then it's probably wrong. You should just rethink it, and these are some of the tools that will enable you to rethink it. The other thing I'll leave you with as a last thought is, if you do not think about disrupting yourself, somebody else will come and disrupt it for you, right? So it's imperative on all of us to think about what we can do with all of these tools now available at our disposal. Thank you. World, right, in e-commerce. So we thought of how we can change it, and this is our take on it, right? So live makeup. Apply live makeup on yourself by just virtually clicking that, and it recognizes where your face is in real time. You can move around in the camera. It will not smudge it all over your face and everything, right? And it will actually show how it look on you, right? Including foundations you can apply, liners, you can apply lip color, whatnot, right? So that's a real world application that we are seeing a lot of engagement from customers on, right? So these are real uses of AR, VR. So again, I think whatever industry you are in, I would love for you to take back something that like these are some technologies that you can go back and think about how is it this could actually enable or transform your own industry. I am really sure that there is and there would be a way that this would be possible in any industry you are in, right? So on the last one that I'll quickly cover, because we lost a lot of time initially due to AR issues, AV issues, I'll quickly try and cover this, which again, this is again further behind in terms of, in my opinion, on the overall cycle. But again, this is going to be equally, if not more transformative to the industry, right? I'm sure there are more discussions scheduled on blockchain now. So people generally think of blockchain and equate it only with cryptocurrency because that is the only application in which this initially surfaced, but that they're not the same, right? Cryptocurrency may or may not really take off. For all you know, it could also be a very powerful driver of how international commerce actually happens, money exchange happens and so on. But even apart from that, blockchain is going to be by itself, in and of itself, outside of cryptocurrency, be an extremely disruptive force in the world. So at a very high level, blockchain is a completely decentralized paradigm where you don't need to rely on a central authority anymore. It's a distributed ledger, public ledger, and it's going to really create new efficiencies by eliminating middlemen. So just these are some of the examples. Imagine a stock exchange that is happening completely on a peer-to-peer basis, right? So when you do today a stock exchange transaction, you are ending up with basically a T+3 day settlement because there is an auditor in between, there is a clearing house in between, all of that stuff, right? None of that, right? No fees, no commissions, direct settlement and instant settlements, for example, right? Open Bazaar is actually, you can think of it as a blockchain distributed ledger equivalent of eBay. It's open sourced and it's starting to gain adoption. Transparency, governance, etc. Right? Middlemen, for example, so one of the big reasons why middlemen are there in the value chain is because they are a trusted party in between the different transacting parties, right? So they essentially act as escrow agents in the transaction, right? And that actually causes a lot of value sink in the entire value chain to go into it. I'm not saying that the middlemen don't add value. Clearly they add value, like some of them transport goods, for example, etc. Right? So that is definitely going to continue, but any value being ascribed only because of being a trusted intermediary or a trusted repository in between and doing escrow business is going to change. Right? So I will not go into too much detail. So again, I urge people to look at it. So this is the closing slide. So these are the two things I'll leave you with, right? So in terms of so I'll just let you absorb this, right? The first one, clearly these are three ideas that that are now really already starting to transform the world as you know it. And the last one is actually is a really nice quote that says, if you've always done it some way, then it's probably wrong. You should just rethink it, and these are some of the tools that will enable you to rethink it. The other thing I'll leave you with as a last thought is, if you do not think about disrupting yourself, somebody else will come and disrupt it for you, right? So it's imperative on all of us to think about what we can do with all of these tools now available at our disposal. Thank you.